Welcome to Kenton's videos. Enjoy the video.
You begin by assembling the minimal but essential stack: varied audio plus aligned transcripts, a modern GPU, and either PyTorch or TensorFlow. Once that is in place, prepare a small baseline model using a pre-built recipe, install libs, validate CUDA, and run a quick demo to confirm audio I/O works. Then split data. Train, dev, test. Make sure to normalize sampling rates and file formats, so the training pipeline ingests consistent inputs before you proceed. You now focus on model training and smart augmentation. Start from a pre-trained acoustic model and fine-tune on your corpus, freezing lower layer speeds convergence. Once set, implement augmentations, add background noise, vary speed, and adjust volume to improve robustness. Monitor dev loss and CER/WER, adjusting batch size and learning rate schedules as needed. Also configure regular checkpointing and early stopping. When training stabilizes, export a quantized or distilled inference model for low. Finish by converting your trained model to a deployable format like ONX or TF-Lite, then integrate it into a simple inference service with streaming input. You should run realistic tests, measuring word error rate, latency, and memory use. Once done, iterate, tune beam width, scorer weights, or pruning to hit targets. If you hit persistent errors, a key troubleshooting step is to revalidate audio preprocessing and transcript alignment. Mismatched sampling or shifted labels causes most silent failures.
Thanks for watching. Consider subscribing if we helped you.